Um, this is another target clear video for A-level AQA. We're going to have a go at a couple of the ZigZag tasks. I have the ZigZag tasks here. We're going to work in C#. Hopefully that helps a few people who are working on C#. Okay, so let's get straight on. Task 1 is to allow the user to enter the word quit instead of an expression. Ensure that the code does not decrement the score on that turn. Okay, so it tells us which of the methods that we need to work on here, the play game method. So we can crack straight on. So a couple of tips, okay, before we start. I've loaded the skeleton code into Notepad, and the idea behind this is that when you're working through on the exam, it's best, well, first of all, it's definitely a good idea to keep a backup copy of the code somewhere, you know, in case you mess up and you can't compile your code and then you can't carry on with the rest of the tasks, you somehow lose it. But on top of that, it's a good idea to keep the code separate for each task that you're given. So you keep each task independent, so you can load the code in for each task. So I'm going to select all this. I'm going to copy it, and then I'm going to paste it into Visual Studio, which I have already set up here in console mode. Load the code in. Okay, so the other tip I would give you is to work in, don't be working in dark mode. If you've seen or ever had to try and mark code that's been screen printed in dark mode, when you get on the wrong side of 50, that can be a bit tricky, and you want to make it as easy as you can for the marker to see that you've basically been able to do the task. You don't want them having to get the magnifying glass out. So working in the background being white, okay, and make sure that when you cut and paste it into the EAD, the electronic answer document, that your code is going to be nice and clear when it's printed out. No real second chances on that. Okay, so this is where we enter the expression. We are in the play game method. Okay, yeah, it's not there. Another tip for you: if you're ever asked a question in the section C and you're asked which method does this happen in or that method happens, always give the method and an open and close bracket on. I've seen students lose marks on the marking schemes because of that. So you always put open and close bracket when you're referring to a method in section C. Okay, so we'll carry on. This is where we enter the expression. User input. Okay, so this is where we're going to be able to read if the user has entered quit. So we can do a simple test. If user input is equal to quit. Okay, obviously we need to put brackets on that. I've not long transitioned to C#. I've programmed in lots of languages before, including COBOL, Pascal, and all sorts of languages, VB most recently, and I still get the languages mixed up from time to time. But here we go. Anyway, if user user input is equal to quit, we can simply do a break. All right. So semicolon. So if we run that now, Okay, and we'll type in quit in uppercase, and the game is over, and that's it. What's happened here is that the break command has just simply ended the while loop and moved on to the next instruction. It's a bit crude, but it does work. It's probably worth the marks. If you want to be a bit more polished with it, what you could do is this. Put your curly brackets in there. And you could put in... so this loop is supposed to end when game over. The Boolean game over is true. So whilst it's not true, which is what that exclamation mark means there, it's going to carry on doing this loop until the game naturally ends. Okay, so what we could do is we could set that game over. Is equal to true. Okay, and then we could go continue. Okay, close curly bracket, and that one is just as effective, a little bit neater perhaps. Okay, and lastly, we could just set game over equal to true. And then we could just do an else, which I think is the neatest way. Maybe I'm a bit of an old-fashioned programmer here, and I like the structure to the code, but this is another way, and this is the way that is in the marking scheme actually for the ZigZag code. Okay, so we'll do this and quit. All right. Now, the question doesn't ask you to do this. It says to enter the word quit in capitals. But if you wanted to be a little bit more polished, show off your programming skills, you could do to upper. Oh, yeah. And that means that the user input is all converted to uppercase, and so however we type in quit now, it will exit the code. Okay, so that's 3 ways of doing it. Just using the break command, using the Boolean value, which exits the loop here, and using the continue, or you could just do what I've just done there, which is the else. I guess if speed is the essence, just go for break. Okay. What is also a good idea is to put in a little comments to say where you've changed the code. Hopefully the examiner knows where to look for the code that you've changed, but it's not there's no harm in trying to point it out to him or her. Okay, so that's number 1. So we can move on to task 2. Now, I'm not going to follow my own advice here, which would be to just cut and paste this code in again. I'm just going to move straight on to task 2. Okay, so this task here is to modify the play game. Oh yeah, here we go. So the question extends the skeleton program by including suitable error messages to the user. Okay, the application doesn't give any feedback for any invalid or erroneous inputs. Modify the play game the check numbers are snappily named. Check numbers are all in numbers allowed method, and check if user input valid methods. Okay, and put these three error messages in. Okay, so the expression they enter does not evaluate to the targets list. So I think I might just copy and paste that. Go to the program. So this is where the validation happens. Okay, and we just need to put 3 if statements in there. Sorry, else statements. Else, oh, still in capitals. Else console dot write line and this corresponds to this if statement. Check if the evaluation is a target. And I think that was the first. Yeah, okay. So we'll just okay. So that's the first one. Mustn't forget my semicolon. And next up, we are on this if statement here. Check that they are all in the numbers allowed list. So the numbers allowed list is the 5 numbers that you're presented with. So I'll copy them. We'll cut and paste that. Okay. Else console dot write line. Okay. And finally, for these 3 tests, we are going to check to see if the user input is valid. So if we just do a Control F now and bring up this little box, which I can barely see, I'm just going to go to this. All it does is that match against this regular expression here, this function, and make sure that it's a match. Now, if this doesn't mean anything to you, I suggest you cut and paste it and put it into Copilot or something. And I would definitely recommend that you revise regular expressions. I'm sure there'll be a Craig and Dave or Mr. Brown CS video on that. So do make sure regular expressions and reverse Polish notation are a key part of all this code here, and I'll bet there'll be questions on that. So else console dot write line. Oh. Okay. And the semicolon. Okay, so that's those 3. Okay, that will bomb out and then subtract 1 from the score. Make sure you've looked at the earlier videos that I've made. I've made a couple more of videos with the code walkthrough and how the score is incremented and or decremented here. So yeah, so that's those 3. Just cut and pasted the wrong one. Need this one. Sorry for the confusion there. Let's make that expression entered is not valid in fixed notation. Okay, bit neater. Okay, so that's that. Now, finally, there's this bit here. The expression includes division by 0. Use a regular expression in the check user input valid to detect this. So we've just been to that. Let's just go to that again. So here's the regular expression that's already there. This is for the full equation, okay? So it says at the start of the string, we want a 0 to 9 value of many, we can have 9, we can have 999, we can have 199, 099, or whatever. And then we have to have one of these, which is an operator, plus minus multiplication and divide. And then finally, it must end with, again, a series of digits from 0 to 9. And that must be the end of the text, which is why we've got this dollar sign. So I've already done this on Copilot. I can bring up Copilot. Okay. So this regular expression here, okay, will detect anywhere within the code a /0. So if the user tries to enter an expression which is a division by 0, this will be picked up. So all we have to do is I'm just going to copy that, and then I'm going to say if regular expression, this is just me being lazy, not wanting to type it out, is equal to that. Obviously, you're not going to have Copilot in the exam. I don't know whether they're going to provide any help with these regular expressions, so it might be a good idea to make sure you're really familiar with them. Okay. We don't need that, and we don't need that. And all we do is we return false, which will exit the code. We could put an else there, but there's no need to. The return false is going to bomb out if there's a divide by 0 in the code. So let's give that a go now. Why is that? Oh. Close bracket expected. Yeah. Okay. Did need that close bracket. Okay. So first of all, I'm going to try 5. Let's go for 8 divided by 0. And it doesn't seem to have picked that up. Okay, I think we just need to put the correct error message, because what's happening, of course, is this is returning false, and which means that false is then returned back to this and of course that says that it's not a valid infix notation. What we might need to do is put or divide by 0, and I think we just go back to that. Okay, so we probably could do we put a console white line, and then put attempted divide by, whoops, by 0. Okay. Semicolon, and we'll give that a go. Okay, let's go for 10 divided by 0, and this time it's picked it up. Okay, let's just try some of those others. We'll try one of the numbers that isn't allowed, so we'll try 10 divided by, oh, I don't know, 6. Okay, does not include valid numbers from the numbers allowed list. Okay, what else do we need to try? Not equating to one of the numbers. Okay, so we'll try 5 times 4, which equals 20, and there isn't a 20 there. Okay, does not evaluate to a target in the targets list, and the last one was not to have a valid infix expression. So let's go 5 space Z. Okay, well, let's just go 5 5. Okay, expression is not a valid infix notation. Do you know, I'm not sure whether I should put that error message in there as well. I don't know whether you get a mark doc for that. I don't know. And that's it. So that's it for that one. So we will have a go at one more thing. Okay. So if I just go to the coding tasks, the next one is a very easy one. Okay, worth 2 marks. So the application currently uses list data structures, but includes some functionality which would be better suited to a stack or a queue data structure. So the update targets method uses iteration on a list to interact with the list as if it were a queue. Because iteration is upper bound by the value max number of targets, it will always iterate the same number of times. So this method will therefore have a time complexity of O1 or ON. The code, however, could be simplified just to interact with the start and end of the queue, rather than iterating through it. So the task is to update modify the update targets method to simplify how the list is interacted with at the start and end indices, rather than going through the whole lot. So what it's talking about is, let's type it in here, update targets. Okay. So you'll see that it does this bit of iteration here. And it goes through the targets, bringing all the targets one by one, by moving each individual target along. So for example, you can see these targets have moved over from leaving 3 spaces there to 2 spaces to 1 space, and it's done that by just bringing the 33, 39. You get the idea. So we don't need to do any of that. Okay, we don't need that for loop. All we need to do is get rid of it. and then we just need to remove add the targets at 0. So again, if you look at your list operations, so targets is a list, the various sort of commands you can do. You can move specifically a named target. In class, we had a list of the Beatles, John, Paul, George, and Ringo. We originally had Pete Best in that list. We did a remove of Pete Best from the Beatles, and then we appended Ringo Starr to the list. In this particular case, we're actually removing it by the actual position in the list. So we're basically removing that gap, and then these others will just naturally move along. And that should do it. And at the end, it will add a target, a randomized target at the end. So let's give that a go. Ooh, still got the program running. Start that. Play the game. And let's see. Well, 1 plus 1 is 2. 1 plus 1 is 2. And you can see that it has moved it all along. And it's appended 1 on. So it does exactly the same functionality. And we've done it by just removing it. Okay. So that is a very easy one to implement. And you may get a question on that. It seems a bit obvious that they put that iteration in. They're going to probably going to ask something about that, I think. Okay. So that's it for now. And hopefully I'll put up a couple more videos for you. Okay. Bye for now.